Hello. Okay, sorry. Hello everyone. Okay, good afternoon everyone. Thank you for joining us today. Today's topic is about trust and beam analysis. So in today's lesson, you will learn about the basic and trust and beam, and then use a space claim and ANSYS structural, static structural for beam and truss for design and modification, and perform analysis of truss and beam. So this presentation it will take about 1 hour. So I hope you can enjoy the presentation. Okay, so before I begin with the demonstration, so I would like to introduce about the basic for the structure. So as you see, the truss and beam are both structural elements used in engineering and construction to support load, but they have a different design and application. So the for truss and beam, usually have many application as a bridge and other structural thing. Okay, so now another introduction. I will explain about the truss. Truss is the structure composed of straight member connected at joint. These members are typically arranged in triangular pattern to form a stable and rigid framework. So usually truss have a triangle shape, which the main purpose is to create stability in the truss. Okay, and then next is about beam. Okay, beam is a straight structural member designed to support load primarily by resisting bending. Beam are typically horizontal element that span between two supports such as a wall, column, or other beam. So basically, the strength of beam are influenced by two factors, which is the cross-section shape and material. Okay, so for this today problem, we will build the structure using this structure, which is consists of the beam and frame. So the material is a balsa wood that this bridge will support external load, brick that equivalent to 160 Newton. So for the material that I mentioned before is a balsa wood. Okay, we can actually in the workbench we can define the material property. Go to the engineering data and then insert all the properties. Actually, this one we can create a new material and then we insert the properties such as isotropic, anisotropic, density, yang modulus, and Poisson ratio. So this is the important properties that you can input. Then okay, so next okay, so this is the material this how we define the material. Okay, next is the truss beam element. So this is the basic structure for the beam and truss. Okay, so I will show you in the demonstration. So now after we define the material, so now we go to the geometry, right click, and then click this edit geometry in the space clay. Okay, now we will take time to open the space clay. Okay, so to save some time, actually I already prepare draft for the bridge. So this is consists of the bottom part and side part. Okay, so this have a dimension as shown in this slide. So this is the exact dimension. Okay, and then but later I will explain how to define the beam cross section and how to convert the line sorry, convert the line to the beam. Okay, so to convert the line into beam, you go to the prepare tab, and then okay, you can go to this beam feature here, and then you can go to profile. Okay, for this one, actually this is the already defined profile. So for this case, I would like to select a new profile here. So for this case, actually you can select variety of profile. So such as this one, L type, L solid rectangular, and then rectangular tube and so on. But for this case, I will just select rectangle. So basically, by default, the rectangle have a dimension of 10 mm length and 10 mm height. So to define this one, if you want to convert this line to beam, just select this, create, and then you can select one by one. So it will now it will convert the line to the beam. Okay, so actually after you convert, you can check here. This go to display and then select solid beam. So you can see here. Now you can see the line already convert to the beam. So but now the bridge is still not complete. So okay, so I just want to now I want to um, copy the other line. Okay, so I just want to duplicate all the line here. This actually already defined as a beam. So now I want to move and copy. So I just control click and then move. So now I set the height is 80 mm. Okay, so now already and then same thing for this beam. So same thing, I just control and then move. And then for this case, I put 120 the length. Okay, so so now already made this structure. Okay, so how do we draw the line? So now we want to create this the last part is a cross basing design. So we want to create this. To create this, actually just go to sketch here, and then select this pane. Okay, and then just select line, and then just make a line here, and then continue with the other part. Okay, so after that you can end sketch editing. Okay, now actually you have the line here. Actually you can do the same step as the previous, and then go to prepare, and then you can select actually you can choose the previous defined beam, or you can select a new one. But for this case, I just use the same setting as the previous one, so which is a rectangle 2. So just sorry click create, and then select the line. Okay, so last step for the last step, just copy this, click on this line, and then control move. Okay, so now the structure is complete already. The or the structure. So you can check the design. So this is the design. Okay. Actually, for the beam profile, you can modify the dimension of the cross section. Just go to this beam profile, and then for example, rectangle, and then click here, edit beam profile. Okay, so now you can change the dimension. Just go here, and then just change whatever value that you desire. So for example, just let's say I change here 40. So the dimension will follow lah. Okay, actually you can see the difference in the display here. Okay, but I think I just want to stick to the initial value. Just go edit, and then same, change back to 20. Okay, and then just close. You can see it go back to the original. Uh, okay, before we go to analysis, okay, we need to make sure that we apply share topology. Okay, share topology is the way to achieve a conformal mesh. So where the body meet, and it's the only way to certain that the intersection of the body is meshed perfectly. So that's why we need to apply the share. So to apply the share topology, just click share here. So okay, the space claim will determine which point that desire share topology. And then after that, just click here, this complete. Okay, now the share topology is already done. So now our structure now ready to go for further analysis. Okay, now we can close the space claim. Okay, just click close. And we go back to workbench, and then right click to the model, and then click edit. Okay, we take time. Okay, so this is our model. So now it's already open in the static structural. Okay. Actually, you can go to display and then check the structure here. Then you can change the display. Okay. And then go to material. Actually, we need to before that we need to go to unit and then select the unit is correct, which is mm. Okay, and then we go to this one, geometry. And then now by default the material is structural steel. So we want to change. Okay, and then click here and then click bahasa word. Okay, so now we already done with the material. So after that, actually you can edit the cross section here. So our this is our default cross section as we defined as base claim previously. So now we want to edit the elements. We go to mesh and then we want to edit the element size. So for this case, I choose 10 mm. Okay, and then click generate. Okay, okay. Now we want to define the simply support. So I just select this point for the simply support. Then click apply, and then click pause, and then the magnitude is 40, and then the location is here. Actually, this is a vector, so need to change to component to negative 40. And then we need to define, we need to put another one is a standard gravity. So at the moment, the direction is negative z. And then we change to negative y. Okay, now you can insert this one for the solution. You can choose a total deformation and other type of solution, which such as beam tool. So at this stage, actually, you can run the simulation by click this solve. Okay, actually, we already get the result here for the structural beam. So you can run. Actually, okay. So actually, you can not only in the space claim. Actually, you can also edit the dimension here. Okay, just solve again. Now I change the rectangle 2 as the length and height is 10 mm. So you can see the difference. Okay. So this is the beam tool result. Actually, this is the result that you can obtain here. Okay. I think I open to the floor for any question. I think I will stop until here, and then I open to the floor for any question related to the truss and beam analysis.
Thank you very much, Dr. Azim, for this informative webinar on this topic. Before we move to Q&A, I will launch a poll. Please select the appropriate response and click submit. I hope you have been enjoying the presentation so far. Now, it's time to address your question. Feel free to type your question in the chat features, which you will find at the right of your screen. We will do our best to answer as many questions as possible during this session. Does anyone have question regarding this topic? Dr. Hazim, we have one question. Can you show the internal forces and moments, Dr. Hazim?
Okay. So actually, so okay. So I'll be back to the simulation. Do you see my screen now?
Yes.
Okay. So actually to display the you can go to moment reaction and force reaction. Actually for moment reaction, you can choose any, let's say any location that you want to, let's say I want to the result in this line or beam. So just and then click here and then just evaluate the result. So now we can get this the value here, the value for the moment reaction, and then for the internal force is the similar. Maybe we can find this force reaction here. Same. This one just click the simply support here, and then every or the result, and then we can get the value. We can refer the value here. Add here. So I hope I already answer your question. Actually, you can obtain other result as well. So you just uh, find what the result that you want, and then you can what you can put select, or you can actually there are what you can define the solution. Yeah, this one by select this user define a result. Actually, this one you need to refer to the table, a certain table, to get the desired result. So
Okay, Dr. Azim. Thank you for answering this question.
okay, got another question. Actually, we can calculate the safety factor. Actually, in the software, also can have the have a function for the safety factor. But for buckling, actually, we need to move. We need to couple with the other. For buckling, actually this is the different already. Because actually we need to couple with got another what subsystem which is the equivalent buckling. Actually, we can couple the static structure with the buckling. Okay, I hope I answer your question.
There is time for more question. Anyone have question regarding this topic? While we are waiting for questions to come in, I like to remind our participant that sometimes it takes a moment for question to be formulated. Do not hesitate to ask about anything related to our discussion today. Silence means no question more. Okay, it looks like we have covered the question. Thank you again, Dr. Hazim, for answering those questions and for the great presentation. Dr. Hazim, is there anything else you wanted to cover?
Um, at the moment, I have no anything to add. So, but thank you for joining us today. I hope we can have another session next session. Yeah.
Yeah. All right. Thank you, everyone. We appreciate you being here. We also encourage you to connect with us on social media to get latest information. If you have additional questions, you may contact us by email or telephone. We are happy to provide additional support. Thank you all for attending. We hope you have learned and enjoyed this presentation. Have a wonderful day.